In fact, in my opinion, one fire is too many. So you're saying I only have to yell like, oh shit, and it turns everything off? We don't work with Bambu because we cracked their encryption. We showed that they were liars. Prusa ever has a fire, I'm gonna dig into them harder than you've ever seen me dig into a company before. Welcome, everybody, to the Making Awesome podcast. This is episode 237. Well, we are talking about fire safety on 3D printers because apparently this is something that we have to have continual discussions about because it's something that never, for some reason, gets any freaking better. So a lot of people saying, thank you for covering this. Let's look at more fire safety. We've had a lot of good fire safety stuff. But then there's been, the people that just don't get it. They just don't get it. You don't mention the conditions under which the user was operating the printers. How many other printers have self-combusted? Your commentary should be unbiased and fair. This is neither. Why do people dislike Bambu? They changed the 3D printing world and the rest are playing catch-up. I said, we only have the data you see, so we explain the facts as we see them. It is unbiased and as fair as we can be. There are many reasons to dislike Bambu, and I've gotten to them multiple times, but yes, they did change the industry, and that's a good thing. We would like to see their machines built with slightly better QC, though. And, part of this is that being the fact that they're hitting such a low price point, it is challenging to maintain that full control over everything that they do. They simply can't do it, right? They're not... Somebody else made these boards. Bambu is not making the boards in-house. It doesn't make sense. It makes sense to have someone who does specialize in making boards to make them. And I'm happy to be wrong, but I'm almost positive.
With their scale, they might even be making the boards in-house. We don't know.
If they are...
We know very little about the internals of their factory setup.
So if Bambu is making the boards in-house, one fire is too many. In fact, in my opinion, one fire is too many. However, there are certain, you can't be held accountable for it because you didn't do the work. But at the same time, you should be checking, but spot checks are not going to catch all of this. And in a production environment, it is often unrealistic to expect a company to do testing on every single board.
I think what's really important to focus on is in that comment, there is one assumption. And it's the big one that doesn't stand up when you look at it deeper, which is you don't know the environment that the person was doing. I literally already can't remember the rest of the sentence.
I don't
but
think
that bit of you don't know the environment.
Right, I don't think it matters.
Safety has to assume it's being used improperly.
Right.
That's the big thing. You have to assume things are going to break. It's how do you mitigate that? That's what safety is. It's not always don't let it catch fire. It's what do you do if it catches fire? What do you do to mitigate the damage that will be caused? And it's also the other aspect of, well, if it could catch fire, how do we stop it from progressing? So the before it catches step, what is the connector, what is the material? All of those sort of things have to be done before issues arrive. So I don't like to dunk on comments, but the assumption that the user is that safety is only if the user's using it correctly.
It's an easy one to dunk on.
Wrong.
Yeah.
You have to assume it's being used incorrectly. You have to assume somebody's going to pull a thermistor out and tell it to heat up. You have to assume somebody's going to cut a wire somewhere. That is part of safety testing. So just keep that in mind for anyone watching. Safety is not about proper usage.
Yeah.
It's about improper usage.
Here's another one. Oh wait, a product shill with 6 Prusas in the background can offer a neutral opinion on a company that won't do business with them. Show me a fire. I see burnt components. A fire is far different than melted components, and many brands have had these issues at one point or another. And to go by the word of a person that may have altered or had bad experience with service as a result of their own making, yeah, okay, let's run with that. That's the comment. My reply to this is, you mean the Prusas I paid for? And I realized after and there's more to it, but I realized that there are 2 Prusas in the background that I didn't pay for. Bambus don't fit on that space, so there aren't a Bambu there. We don't work with Bambu because we cracked their encryption. We show that they were liars. We hold them accountable. Ooh. We don't work with them. I said, and if you think we shill products and don't disclose sponsorships, I recommend you contact the FTC because that's a federal crime that we've committed. Every single time that we talk about products that we have a association with, we disclose it because we have to. It's the law. I said, Bambu will gladly take my money, but they won't send me free things, to shill, like some of their creators do, because we found the truth and they don't like that. Did you see those boards? Come on, man. There is a fire. I've covered every case of fire that has come across my desk. See the Chidi fire issues as a perfect example, but at the same time, we presented a very fair and reasonable response to all of these. If you have issues with this, go back to your echo chamber. We had a few people that were just very pissed. Just overall pissed that
I want to put stress on it's not a Bambu thing. Fires is just fire. It can happen to any machine at any point because it's equipment.
Anytime.
I mean, hell, how many Prusa fires have we known of? I think I know of 2, and that was due to the Mark III's thermistor foiling issue, which is again acceptable.
I'm aware of more hot ends melting on Prusas, and that was an E3D issue where the alloy was messed up, and when they would go to print temp, it was hot enough to actually melt.
Oh, it just melted the alloy.
Melted the
I
heat
remember
block.
that.
And every single time Prusa has been on top of it, and I'm still bummed. I was trying to get one of those melted hot ends because I wanted to do a test on it and determine what the alloy was. I would also
I want to put stress on it's not just a Bambu thing. We're not dunking on Bambu. It's just that is the hot topic, pun intended, that's come across our desk for this topic.
I want to be clear that the Print Fix Friday video was more about what we see. It's not about companies. We were talking about this before we went live, but if Prusa ever has a fire on the next router system, I'm going to dig into them harder than you've ever seen me dig into a company before because they don't have an excuse. I've seen how Prusa makes their boards. They test every single board. Every single board gets tested. Now, they don't all get 3D X-rayed and things like that, but every board on their line gets tested. There are no excuses for the way that Prusa is designed right now as a company. There are no excuses for Prusa to have fires with any of their current components at all. There's no excuse. It would be nice if we saw more V0 materials.
That's something I wanted to cover was how do you design hot ends and printers for the risk of printing? Printers are not a safe piece of equipment.
They're
inherently.
Freaking heaters,
they get hot. They have high power electronics and vibrations. Those are the things you need to normally deal with the least in every other piece of equipment.
They're the 3 things that in terms of product design, you try to avoid as much as possible. And yes, I know this is an old V6. These could have upwards of 60-watt heaters in this little aluminum block. And these newer PTC style heaters, while they don't create thermal runaway cases like the old school ones did with the ceramic heaters that would just heat until they catch fire and melt, the PTC ones are straight up just limited by resistance and how that whole PTC system works. They are inherently safer, but they're not inherently safe. And, we saw initially that Bambu had issues with their thermal runaway protection. They fixed that very quickly with a firmware update. And that's one of the nice things about having a machine that is so well connected like the Bambu is, that you're able to just push a firmware update to everybody and it fixes a thermal runaway issue. And because these machines are internet connected, it can be an OTA update. You don't have to physically like compile the firmware and things like that we had to do back in the day. So there are some reasons to like the current Bambu ecosystem, but because they're such a large company, my assumption, whether or not this is accurate, but I would say that our assumption is that they are not producing their own circuit boards in-house. And because of that, you can't guarantee any quality off of it unless you're checking every board. And with how many machines they ship, that's not realistic either. So, like, do we
And I should say, the reason we think that is because it's a few machine failures with similar failures within a short period of time.
They were all purchased at the same basic time. They all have roughly the same amount of hours on them, and all the failures happened within a short period of time. So, like, we are assuming they are related. We're not certain if they are, but I don't think it's unrealistic to say that, okay, there could be a component issue on some of these boards.
It could be something as simple as like the solder that they added in just that one area was slightly too,
it could have been cold,
reduced.
Yeah.
Like it could have been cold. They could run out of solder as they were feeding more in, and it's just a bad joint. It could be a bad connector from whichever connector supply they get. Like it could be a wide variety of things. The bread and butter of issues is you can't actually tell, is it the design of the board? Because it could be that, let's say Bambu Lab is getting an external company to make the boards. You don't know if the external company designed the boards or it's a Bambu Lab design. That is one of the things. It's like, so I just finished talking with a custom motherboard maker about toolboards, because we're looking at getting our own toolboards made. And one of the things that was quite surprising is they commented that a couple of the toolboards on the market at the moment, they know will overheat within the parameters they say it won't. And that's because the testing that they've done is not as comprehensive as the real world. It passed the test results, it doesn't pass the real world sniff test to them. And that was quite interesting. So it could just be like this is an oversight on the design side. They designed it to be safe, but it doesn't pass real world usage, if that makes sense.
And then there's like the argument of, you know, how many machines has Bambu shipped? This is such a small fraction of a percent of machines that have issues. And yeah, I can understand that, right? There is part of me that's like, okay, that's fair. And yep, you don't know what use case these machines are being used in. Maybe they are being abused. From the photos that we can see, that doesn't appear to be the case. When I look at my X1 Carbon, which is the only thing that I have as a ISO standard to compare things to, every single one of the connectors on the X1 Carbon have this white silicone glue on it. And that's there for vibration isolation. It's there to keep the connector secured. And when we looked at the photos of all the P1S failures, none of them had this glue. Now, none of the P1Ss that I've seen photos of have the glue on the back either. So I don't know if that's intended or something like that, but it is something to note. Is it an issue? We don't know. But it is something to note that Bambu is aware of the vibration that these machines create. It is not uncommon for things to come loose. And I think they've done a decent job of dealing with that. But do we look at these three issues as saying this is indicative of a larger issue, or is this just firmly isolated, we have nothing to worry about, and that these users so far are going to get their issue taken care of? That's the real question that we have. And I'm not certain that I know where I stand on that. Like, what I want is a public statement. I don't think we're going to get one.
I don't think you're going to get one.
No.
The amount of machines they sell a year is, from the last numbers that I've heard of, they sell roughly 10 to 15 machines per Prusa that get sold.
The question
and
is,
I know Prusa announces their numbers, which is like 110 to 150,000 machines a year, which means Bambu Lab is easily probably selling in the million machines a year.
But do we deserve a response? right? It's not, I know that I want one, and I think a lot of people want it. Do we deserve it? That's the question is, do we deserve it? Right? Does Bambu owe us a response?
What type of response do you want? Would you be happy with just a media manager saying, hey, thanks for bringing this to our attention. We've not seen any like data tracking of this, so we've opened a ticket and we're going to investigate this? Or would you be happy with like a blog post where they are like, this has come across our desk and now we're doing this to rectify and all of that? Like, what level of response do you want?
And that's kind of the trick. I'm not certain. You know, Nick T said Chidi has 0 machines burn, but their heater relay was very dangerous.
Is that true? Because what was the thing that started the investigation was somebody noticed a smell, wasn't it?
Right. Yeah, it was a smell. It never... So there is still that unknown of the house fire with a Chidi printer that was present in the house fire. Looking at the photos, I don't believe the printer had anything to do with it. However, I'm not an insurance investigator. We are still awaiting that report. We were seeing copper get discolored from the heat, right? We had people state that they were smelling smoke. And in my testing, we saw that the linear choke get up to over 200 degrees Celsius, which is not safe. It was it was on every single 110 volt unit that Chidi shipped had this issue. And it is very clear that they did not do adequate testing. Bambu is not the only ones that have had these issues. We've seen QC and QA issues. But I dug into Chidi so hard that I'm fairly certain I'm blacklisted at this point. And I don't care. People's safety is more important to me than free printers or getting paid to show machines on the channel. Like, their integrity matters more. And some people see that as we are attacking certain brands. But if certain brands are the ones having all the issues, that's not on me. That's on those brands. And if you see fires from other brands or potential fire safety issues from other brands, please tag us. We want to look at it. We want to alert people. We want to be able to inform the consumers so that the consumers don't end up with insurance claims. Because I promise you, your insurance claim will cost you more money than the machine is worth every single time. I don't think the P1S is a, like, OMG fire hazard like the Chidi tech absolutely was. The Plus 4,
I think a lot more machines in the market are more dangerous than the P1S.
Yeah, but I do want to determine what happened and what was the root cause of the issue. So we know that Bambu does make updates, right? We know that they make updates to their hardware. In fact, I experienced this when I went to replace one of the tool head boards in my X1 Carbon that had a connector break off of it. Because, oh yeah, they're glued in place and they're kind of hard to get out, right? So the connector broke. Well, I couldn't just get the one board that I needed because they had made a hardware revision and they no longer supported the older boards. Okay, so I had to buy this whole new board system. No big deal. Instead of $20, it was $50. So I was a little bit bummed, but still, that's a cheap fix, right? $50 is still a cheap fix for a $1,000+ machine. Was this the case of a hardware revision that maybe resulted in a different use case scenario? Like, because we know that they make these hardware revisions without really alerting users to the fact there is a hardware revision, this could be because of that. I think it's more on the manufacturing side, like a cold solder joint, something like that. To me, that's more realistic.
Yeah. My gut feel is it's a manufacturing fault instead of a manufacturing design oversight.
Yeah.
However, with that being said, these are also aspects that should be considered when designing something. Is what happens if this joint is faulty? What happens if this joint is under-designed? And that's where we kind of start merging into the scale of Bambu Lab. And this is for any company, bearing in mind, is when you get to a certain size, you need to optimize everything. You cannot go with the, just double the thickness and it'll be good enough. So you will have a guy sat there, their entire job is value engineering.
Yep.
That is the entire job title of them. You can get a job in that, and it's actually a really well-paid job, value engineering. We're making minor adjustments to maximize throughput or productivity or like minimizing material usage. That's their job. And this could be one of those cases where they've got a new revision, their value engineer came in and they said, hey, this solder joint, yeah, we can make it 0.2 millimeters smaller. Over 100 boards, we will save $50. And that is their entire job, is to speed things up, make things cheaper, and keep the safety the same. But it doesn't always work that way.
Right.
And this could just be the effect of adding that extra step in.
It could be. We've also seen where manufacturers that produce the raw components, like capacitor manufacturers, power connector manufacturers, will cheap out as well. We saw this on the Q1 Pro issue from $199, Print Fix Friday $199,
Yep.
where myself and J-Lo both agreed that this was probably an exterior source saying, oh, you can save a bunch of money if you go with this, it will still work perfectly fine. When in reality, it wasn't good enough. And is that a good excuse, though?
It's very easy for a company to do that, because especially on cheap machines, every penny you save is much more focused on than more expensive machines.
It results into tens of thousands, if not hundreds of thousands of dollars on your bottom line down the road.
It's like, I spoke to a zip tie manufacturer, and they were literally telling me the importance of saving 0.01 pence per zip tie. Because the parts are so small, the amount of material goes into them is negligible. Therefore, though, that micro saving, that 0.1% is such a huge impact when you scale it up. That's where they actually earn their money from. Because otherwise, if you are that 0.0001% more material, you are now losing money. And it's that really fine game. Obviously, when you become more expensive, the allowable tolerance grows with it. So this could just be the effect of value engineering. I don't know, but it's something that we can definitely discuss further, because there's a lot of aspects of value engineering that not a lot of people focus on.
I made the comparison of like a $3,000 versus a $1,000 machine, and that the $3,000 machine, should have better components. And a lot of people are like, well, no, not necessarily. And there is a solid point there that some companies will just charge you more money and not give you a better product, where other companies will charge you more money and give you a better product. And so that's fair. Then there were the people saying, oh, well, the average consumer doesn't want a $3,000 machine. They want a $500 machine. Well, is the average consumer willing to take the risks that come along with a machine that's been heavily value engineered, right? The second fire, well, I guess it would be the fourth fire, but the second, non-P1S fire that we saw was an A1. That is now another case of an A1 catching fire. We've seen the power supply catch fire. Another one did, by the way. Another A1 power supply caught fire. This A1...
We've had the bed wire.
Yep. And that was a recall. That
was recall.
That resulted in a recall. And, we said this was creating fire. People are like, oh, no, there's no fire. I'm like, there's burn marks. There's fire. I'm sorry. I understand that you don't agree with me, but you're wrong. There was a fire. And we saw with this A1 that the individual reported that there was a fire and that their significant other blew out the fire. And we even reported on they probably should have turned it off when it didn't come online. And so there is something to note there, that there is some onus of that on the user. But, and it's like people just, I hate that this is the way the world is, that the only way we get change enacted is, one, if we're loud and proud about it and, basically force companies with threat of canceling that they solve their issues, or two, somebody dies. That's the only way that you get change in this industry, is either you call out a company enough that they just throw up their hand and say fine, or somebody dies. And at that point, you can't ignore it anymore. And I guess maybe the death is potentially a bit hyperbolous. It would be more of like major true. House structure fires or things like that.
Until something catastrophic happens, unfortunately, the law doesn't really care.
No.
Like, while it's written in every directive. So, for example, one of the things that you have to do just to get CE, and I want to repeat to everyone who's watching, CE is kind of a lie. It is the lowest level of safety you can reasonably get away with to then go into production. You can pretty much, except for like one or two things, sign off on the safety side itself. I even know people who can argue the fact that they didn't know what they were doing meant they could sign the CE documentation and get away with knowing it was wrong, because they're not designed. Well, CE is not supposed to be a you know what you did. It's a you signed off that you believe you're not maliciously selling something bad. That's what CE means. Well, so unless there is extra testing, even that is really, it's a low bar. And unless somebody gets hurt, nobody's going to investigate.
And malicious, right? That term, these companies are not producing deliberately malicious things, right? Bambu is not producing deliberately malicious things from our perspective, okay? So would they fall under CE? Probably, right? But you have the next step in the US, which is UL, right? UL listing. And that's a racket in and of itself. I can't recommend that people go down that path because it's tens of thousands of dollars. And it's like 3D
it's
printers,
very expensive for not much results.
And 3D printers, because of the heaters and the systems that they have, probably just don't inherently pass UL safety standards because of the open heaters. Right.
Oh, no, they would still pass on that, but they would fail on so many other areas, like the type of wires used. It comes back down to all of the corners cut.
Yeah.
Means there is a high chance they would fail. And one of the things that a lot of people don't seem to realize is if you fail on something, just change the classification of your machine, because consumers don't care what that classification is. They'll buy it anyway.
They also don't know the difference.
When we were doing our EMC testing, we chose to go for I won't say it now because it becomes the point of what I'm going to ask you in a second.
Okay.
But we chose a specific classification we were targeting for our EMI and EMF equipment banding. So if I told you we were band 2, do you know what that means?
Nope.
Nobody does, unless you know what that means. If I told you, oh, we've made construct 2 band 1, do you think that's better or worse?
I mean, first is first, okay? And 2 is not a winner, and 3 nobody remembers, as the philosopher Nelly has once said.
Yep.
So, yeah, 1
it's
sounds
actually
better.
2 is better than 1. 2 is a higher standard. It means home use. 1 means industrial use. If we failed band 2, we were 100% with our right to go, no, we're band 1 now, and we can sell it anyway. That is it. And if we failed band 1, we just have to put a little mark saying we're band 0. That still signs the CE certifications, even though your machine can literally turn pacemakers off.
That's upsetting. There does need to be some sort of standard. And, again, I don't think that Bambu is directly at fault for this. I think that there is a board manufacturer. Whoever's manufacturing the boards, to me, is ultimately at fault here, right? If this was something that was Bambu fault, we would see it on way more machines. Like, let's say it was a firmware update that all of a sudden put way too many amps through a connector. The connector was melting, solder was melting, things were catching fire. You would see it on 50 printers overnight. I believe the onus on these Bambu fires is more so on the board manufacturer, but without knowing who that is, there's no way.
I want to push it off of the manufacturer and onto the design. Because it's the connectors and the traces.
Well, maybe. So if the board manufacturer decided to swap for a like component, so let's say,
okay, I'll give you that.
Yeah, like if this was a board revision and the board revision is the thing that created the failure, fine. Then that's on whoever designed the board, which in this case would likely be Bambu themselves. This feels like a bad production thing, whether it was cold solder joints, bad board design. More likely to me, it was the manufacturer value engineering something and not telling Bambu.
Look at all of the bloody problems that NVIDIA are having with their high voltage connector. They got rid of the power balancing. Like, they just turned it into one massive, like, resistive bus instead of having individual power balancing. So if one of them failed, it would load the rest with the remaining power, overheating it, causing a fire. Whereas the original connectors, and ironically in the original design spec, each one had a power monitor, so if it was not doing the right job, it just wouldn't fail. It would stop itself. And that's something you could have added. Like, you can add checking hardware, you can add checking software. Hell, they could have monitored the voltage or the wattage draw and gone, well, if it's drawing this amount of power and it's not doing this amount of work, there's a mismatch, something's going wrong somewhere else.
Right.
That is literally thermal runaway, but you can use it on other aspects of a machine. It doesn't just have to be on a heater. It can be on motors. Like, if your motor is now suddenly drawing 4 amps and it's designed for 2 amps, maybe there's a hint that maybe your motor controller just died. Like, you can check that. You can turn the machine to a safe state.
I would like to believe that Bambu's can do that. I don't know if they can, but if you want to talk about a connected printer, they are the perfect example of a machine that is so well connected that it can determine when it's failed. They were the first company that I'm aware of to integrate AI fail detection right into the machine. And from a user perspective, super bloody cool. Love to see it. I don't particularly care to use it, but I think it's super freaking cool. And if you are trying to get into this industry, that's kind of a big problem, is detecting failures. But it does feel like they spent more time on detecting print failures than machine failures. But did Bambu ever expect their machines to get used and abused the way that they do? Like, could we even point fingers at the users for not properly maintaining their machines? Is this something that we need to check? Like, it would be nice.
Okay, I'm going to stop you there.
Okay.
There's one thing that I will always stand by. It's never the user. When it comes to safety, it's never the user. It's the manufacturer. Like, if I sell a machine and you can cut a wire and then the machine can kill you, that's not the user's fault. That is the designer's fault for not doing a design that is inherently safe. There are things you can do to make machines safe, bar them sticking a pin directly in the power supply. But actually, no, even that is something that testing covers.
Well,
ingress protection, general product safety protection, they cover stupid people cutting wires. So that is something you can test for. Like, you shouldn't buy a printer and then put a fire extinguisher next to it. We do that out of precaution, but in reality, the machine needs to be designed not to catch fire. And if it catches fire, the machine needs to be designed for what happens when it catches fire. Like, I'm not going to pretend like machines don't catch fire. Every machine, if you build enough of them and they run for long enough, will catch fire at some point, because wires will degrade. The chance of something going wrong happens all over the time. Like, I literally have a log of machine like damage and failure and shipping stuff and all of that, so I can track severity and likelihood and all of those sort of stuff. That's stuff we track to make sure the machines are safe within a certain safety boundary. What we don't pretend is there is not a peak where the machine just explodes the moment you plug it in, because that is safety. Like, we have to be prepared for that. So it's, how do you do it? Well, let's say the power supply is faulty. Like, it goes in shipping, it takes a 5G load. Bearing in mind, our power supplies are rated for 3.8 Gs for 15 minutes. Let's assume the power supply is damaged in some way, that the moment you plug it in, every capacitor in there is going to go nuclear and your house is going to explode. So how do you stop that from happening? Well, you add fuses. You change the wiring so it doesn't allow for that level of power draw to go in before the wire fails. You add a fuse at the start of the wire and the end of the wire. So even if you start dumping that power, the fuse blows before the wire blows, before the power supply explodes and your house burns down. That is designing for safety. Value engineering lowers that level, but it still needs to be that. So I would always argue every machine fault we've seen is the company's fault, not the user's fault.
So like I every time that we have something like this, I always think back to cars, right? So like cars have scheduled maintenance. Every 3,000 to 5,000 miles, change your oil, right? And if you're using full synthetic, maybe go 10,000. I change my oil once a year because I put maybe 4,000 to 5,000 miles on my car. I change it once a year because oil's been in the ground for millennia. It can sit in my car for a little bit longer. Don't care. And my car leaks a little bit of oil every now and then, so I got to add oil. So really, I'm doing a consistent oil change. I'm really just doing a filter change when we think about it. But like, if you don't change the oil in your car, it's not the car manufacturer's fault.
I would argue it is.
It's not. The car
should have a sensor monitoring the oil, and it should tell you change the oil.
They all do.
Now, if you ignore it from that, then it's the user's fault.
Okay. And that's fair.
But
that's fair.
The machine, I even know cars that go into a limp mode if it notices there's metal in the oil. Like, that is good design. That is like good, safe design. Is they're not stopping you from ignoring it, but there is contingencies in place to keep the equipment safe, keep you safe. Because what happens if you override a safety and you keep driving and then the car engine just dies on the motorway and you kill someone? Well, you're going to sue the company for allowing their machine to be that dangerous on the road. But it's not.
Yeah.
Because they did their job. They put the safeties in. So why put safety on the user, which is the most dangerous thing? You know, you're expecting you to maintain a deadly piece of equipment? No. I'm sorry, no.
I think that this is... So our differences here is a really interesting difference because you are approaching this from a manufacturer. You are approaching this as someone who builds safe 3D printers. I'm approaching this as a user that's also a moron, right? So like, I killed an octopus board. That's my fault. That's my fault. It's not the board's fault. I shorted. Was there a time where that should have been fixed? Maybe. Do people kill motherboards all the time? Damn right they do. They're also cheap enough that we don't care a ton. Now, a machine having this issue is a little bit more of a problem. Because like, if the user is in there messing around with wires and stuff, I have a problem with that. Because at that point, yeah, you could say the manufacturer should do better, wire control and, cable management and things like that. But dude, I've cut cables assembling a machine before, and I had a solder live
as well.
on YouTube because I cut cables accidentally. But I'm also like, I'm reasonably responsible, and many people aren't. And maybe that's where the difference is that I take responsibility, and I'm not gonna blame Big Tree Tech for that failure. It was my fault. I'm pissed that it didn't, pop, spark, and let the smoke out, because that would have at least been fun. But it's not Big Tree Tech's fault. It's my fault. Because I take responsibility. And maybe that's the difference, where people are more willing to point fingers at manufacturers versus themselves. Like the one where the A1 caught fire, I think that is very much a 50-50 shared responsibility. It should not have happened, but as soon as your printer didn't boot up, turn off the power. Now, the machine should have turned off its own power. I don't believe that machine...
Exactly. There you go.
Right, but common sense does tell me to turn it off. Now, if you're not thinking...
There you go. That's where it's gone.
I'm assuming common sense
should know the manufacturer should have common sense, not the user.
I guess I'm assuming that I operate with common sense, and when I don't, I take responsibility for being an idiot. And in reality, not a lot of people do. I agree that the A1 should have an ability to determine that there is a short. It shorted. That is why it caught fire. A short occurred, it caught fire. Because there's really no other way that that fire occurs in that area of the machine without some sort of an electrical short. I think that's fair to say, right?
Yeah.
The machine should have some sort of short detection. There should be a fuse or a breaker or a GFCI of some sort that determines that, hey, there's an amp load here. But let's play devil's advocate a little bit further. Let's say that was the heater wires that shorted. I feel like there's a shared responsibility here. And maybe it's not 50-50, maybe it is 90-10, but like, and like even the user said as much that, yeah, maybe they should have. But I can certainly understand that if you're trying to document what just happened, maybe you forget to turn off the machine. That's where, to me,
I would argue why, let's assume the user doesn't even know how to turn the machine off. Why should the machine be dangerous if you didn't? Why can't that be designed around?
That's not wrong. I don't disagree with that. I'm now curious as to how many machines, given a dead short, would not turn themselves off.
On our Kickstarter video, our end of the video, I send a print file to the printer and our logo appears on the screen. What you don't know is that printer fell off the back of a plane 2 weeks earlier, literally broke every part of it, and we cobbled it back together, did all the printing and the videography with Joel Telling. It was amazingly stressful, an absolute testament to how robust those machines are. But one of the things that we didn't know at the time, because you do a Kickstarter before you actually go to production, is we had a safety fault. Quite a big one as well. It was an egregious one that ended up changing quite a lot of the internals of the machine because we did the testing. We were pulling too much power through the bed. So we had a 480 watt bed in the C1.
That's pretty spicy.
On 24 volts. It was a very powerful
24
bed.
volts?
24 volts. It's a lot of
20 amps. Yeah, that's pretty spicy.
So we were averaging 18.9 amps on our bed. The MOSFETs, so I did all my checking, just like still at the time, I was quite new at this. We did all the checking on the motherboard. The MOSFETs are rated for 22 amps. The connectors are rated for 32 amps. So there's a nice headroom. We can live with it.
22 is a little closer than I would like, but I mean,
it's close to the sun, but you're in the shade. Like, it's still hot.
It's better than some manufacturers.
It's okay. That was my mindset.
Yeah.
Now, one of the things that we didn't realize at the time, and this is a really good example for this story, is Duet, the motherboard manufacturer, are mega giga chads, because they knew somebody like me is going to come along and ruin the design of their machine. So their machine has replaceable fuses in any of the live power and the DC power to go to any heater.
It does.
Has a replaceable blade fuse for a car. They put a 15 amp fuse in. We blew that fuse every single time we turned the bed on for more than 15 minutes at a time because it would just melt the fuse. So this is where the good design comes in. I replaced the fuse with a 20 amp fuse. The fuse now does not blow. What they designed instead was the connector that holds the fuse in place is slightly thinner at one area. So if you ignore the entire fuse and you just bridge it, there is still a safety in the motherboard. So even if you ignore their safety, it will break the motherboard before it damages anything further downrange. So if I shorted out the bed and I was drawing 50 amps, which I have done before, the motherboard will die in a very safe location instead of anything else. And then it will stop that propagation of danger. That is good design.
That's great
design. That is what we can do as a designer.
Yeah, you're literally protecting users from themselves.
Honestly, the Duet motherboards are one of the motherboards I will never compromise on. They have made some of the best hardware on the market, and they have shown a level of due diligence that nobody else has. And for that reason, they will always get my seal of approval.
Where do we stand about fire safety protocols for 3D printers, because we can only kind of get on manufacturers so much.
What do you mean by protocols? Like, elaborate on that, because I don't know what you mean.
What can the average user do to somehow, maybe, possibly attempt to protect themselves with this? How can they protect themselves from fire?
Let's assume EU doesn't exist anymore. It's just the US where they hate you, and safety doesn't exist. If you want it to be the ultimate safety, I'm thinking from like a factory point of view, because this is how I would contextualize what I would do if I was building a print farm and I had 100 machines where the likelihood of a mistake is 100 times however many machines I've got. So I would say smart plugs is a big one.
Yeah.
Like, remote controlling your smart plugs is such an easy thing because you can automate systems on that very well.
Yep.
Add a thermal sensor. Doesn't have to be a thermal camera. It just needs to be in the highest position of that building where the heat will collect. So if something catches fire, the heat will rise and you can go, hey, the temperature of the ceiling is 60 degrees, which is above like any normal use case. Turn off all the plugs. Like, just instead of a breaker, you just use your smart switches to turn everything off.
I like the idea of a thermal sensor, because, like, to me, it's a smoke detector, but thermal detectors kind of better. I don't know. You could put both.
They do different things. So I went to Autodesk, their UK HQ branch, and one of the things they've got in all of their rooms is a thermal sensor, a humidity sensor, and a noise sensor, and they monitor all of them. Their entire facility is smart connected.
So you're saying I only have to yell like, "Oh shit," and it turns everything off?
Pretty much. Like, it's for hearing protection, so they will tell you if this room needs hearing protection or not.
Oh, okay. I thought it was
really
like some backwards way of determining if there were failures.
No. But one of the things they did tell me was they can use that for other automated systems. So let's say a 200 decibel noise happened. That's not normal. So they can immediately flag a system
That's an expensive
and start
noise.
something automated with that. That's an expensive noise.
Yeah.
And they had some very expensive equipment in there. But those are things that you could do. So if I was setting it up, I would buy a $10 smart switch as the very first purchase I made, and then probably a CCTV webcam. Just straight up a webcam. Because if I'm ever questioning anything, I can go in my webcam and turn a plug off. That's an easy one to start with. It's nice, it's cheap. It adds a layer of, well, I can't automate, but I can at least be there present when I'm not present.
I would say, at least in the US, Wyze, W-Y-Z-E, get a Wyze cam, get a Wyze smart plug. I particularly have been enjoying the Casa by TP-Link, but the problem with them is the data security is zero.
They changed. So I had one of the Casa cams before they added a subscription.
I don't use their cameras. I use their smart plugs. Because they make really affordable smart plugs, and they make smart switches like that are on the wall. And I have one set up in my audio room for lights, for dimming and things like that. I have smart switches on some of our printers, and I have smart switches on each of the banks. So each of the row of shelves has its own smart switch or smart plug on it that can then control it. And all of that goes back to an APC or a UPS unit that can output more amperage than the wall can. So I will blow a breaker, the UPS trips, that signals everything else to send warnings and things like that.
So I'm going to go one further, because there's something you can do with just a smart switch. And I can't believe I didn't remember this, because it was one of the whole points I went to Autodesk. And one of the things they really like about our printers, but you can do it with any Clipper printer, I believe. I'm not familiar with Clipper, but you should be able to do this because there's an internal model of the state of the machine where you can just query what is the temperature of the thermistors, and it will give you a number back. You can automate a system where if that number is out of a certain range, it automatically turns the plug off.
Yeah.
So if your thermal safety doesn't kick in, if
thermal runaway protection doesn't kick in,
stops working, like it tries to turn, let's say it's a relay failure, because this is legitimately one of the problems with thermal runaway detection, is it doesn't protect. A MOSFET fails closed,
and they latch closed,
so it is dumping power. That is a bad situation, because your thermal runaway protection, which is only software, will fail because it cannot turn it off. So you need another way to turn the power off. That is something you could do. So you could set maybe like an automated flag in Clipper, or an automated like query if the Clipper is connected to your local network. I don't know how Clipper works. You can query the entire object model of a Construct One printer by just HTML internal code. Super safe. It's really good. It means you can do quite advanced things. Clipper should be able to do the same because they've got feature parity. You can have either an automated system externally or an internally automated system where if either one reads a temperature sensor is well above what it should be even after thermal runaway protection, it just turns the power off.
Yeah, it just straight cuts the power. Okay. I like away. That. That is nice.
You don't need a camera. You don't need anything except a smart plug.
Yeah.
And maybe an hour of time to figure out how to set
stuff. I like that. That's an interesting system. You know, we just have fire extinguishers and we don't generally print unattended. I'm here all the damn time. And if we are printing unattended, it's machines that we have validated, they are trusted, and they're insured. So I don't really care.
See, I don't like fire extinguishers.
I don't either. They make a huge mess.
It's not even that. They rely on something you can't always have. You being present.
Right. The automated ones, like the fireballs and things like that, and the Wham Bam clouds, there is some value to that. However, those require big flames. They don't just require a little, match lit inside your printer. That's where a thermal sensor might be really valuable to detect thermal anomalies.
Those fireballs don't fix the problem. They only delay the problem.
Well, I mean,
if it's an electrical fire and it's still getting electricity, it's going to burn after the CO2 disappears.
And that's where a thermal sensor would actually be really valuable. I do really like that. You could do a blaze cut system, but blaze cut is very expensive. And when it blows, it only blows over the fire source. And at the point, like you said, Jacob, if you already have a fire, it's too late. Where do we...
I mean, we're getting back to that level of it's not on the user, it's on the factory. Saying.
It is on the factory. It should not be on the user. But it kind of is. At this point, we have determined that manufacturers are not checking to the level that we want. So what are we supposed to do? I say the easiest thing is don't do lights out manufacturing. Blaze cut is a tube with some sort of gas. It's some sort of liquid that instantly vaporizes into a gas. And wherever that tube gets punctured, and it's punctured by fire, it takes that liquid, it then instantly vaporizes, turns into gas, and then puts out the fire. They are both one-time use. Blaze cuts are much more expensive. They are like fully safety rated. You put blaze cuts in like race cars and things like that. They're designed for that kind of use. I go down rabbit holes of understanding safety very often. And I found they had an Australian phone number. It was a penny a minute to call Australia for my Google Voice number. So I spent 50 cents to call them for almost an hour and had a great conversation, learned a ton about how their product works, how it could be useful for what I want to do, but it's not going to prevent any fire. It's going to cool down the scenarios. And it was a very, very interesting process, and I'm very glad that I took the time and money to do it. So that's what I can say. And from my discussions with BlazeCut, I do trust them. I trust the work that they do, and they go through the testing. And they have the proof that it does work. And if you are ever buying the fire suppression systems for Prusas, those are blaze cuts. That's what they use. Prusa uses blaze.
That's pretty cool.
Yeah. And so, in my opinion, if it's good enough for Prusa, it's good enough for me. Prusa says a blaze cut's good enough to take out fires. Great. I say the same thing. But for as many machines as we have, it's fundamentally too expensive.
The amount of A1s that have been sold, or the amount of P1s that have been sold, is staggering. And 3 machines out of all of that is nothing. It's a statistical 0. However, it is still something that needs to be tracked, where it could be indicative of a bad batch. It could be indicative of a wider systemic failure. In reality, I think it's a bit of both. Like, they have so many machines, the likelihood of problems happening concurrently is quite high, because you multiply whatever your likelihood is by the amount of machines.
Yeah.
And if they've got 1 million machines, well, at some point a machine will catch fire. It's the infinite probability theorem of no matter what the probabilities are, if there's an infinite chance of you doing it, it will happen. Because anything times infinite is yes. It's the same thing.
Yeah, I of course, we will continue to state that 1 is too many. But this is a statistical probability the more machines that are out there in the field. I don't believe that the average user should be worried like the sky is falling, because it's not falling. But looking at where these failures are occurring and how they are creating fires certainly gives me cause to amend my preventative maintenance schedules. I never look at the back of the damn tool head, but you can bet your sweet ass I'm doing it now. You can bet your sweet ass I'm doing it now, because I'm not putting up with that potential of a problem in my shop. I worry about education institutions and things like that. I worry about schools that don't do preventative maintenance. I worry that they are susceptible. And when you have a school that has a fire from a 3D printer, insurance companies just go crazy over it. And then companies like 3D Musketeers, we can't get insurance when this stuff happens. We will literally get dropped by our insurance carriers because they think it's too much of a risk. Even when we tell them all the stuff that we do to mitigate the risks, they don't care. They don't care. They care way more about, not paying out. So they'd rather just drop us instead. I never want these problems to happen. And I think that the more machines we get out there and the more companies push price points lower, like the freaking Snapmaker machine at $680 for backers and all of that, like, call it $1,000 when it's done. Dude, a tool changer at $1,000, that's like mildly, It feels risky to me. It's so cheap. And what are we giving up for safety? Do I think the Prusa XL is overly expensive? Yes. Do I think there's a reason? Yes, I've seen the reason. They have a lot of testing. And while, yes, a lot of that testing was done before the input shaper stuff was on that machine, it's still a decent machine for the money. And probably the best tool changer on the market currently. Do I worry that the Snapmaker, as cheap as it is, has some potential issues with fire safety? 100% I do.
Yeah.
Especially considering that Snapmaker has shipped machines that use bang bang heater control and not PID. Right? So I don't know. I worry that it's going to happen more to people that don't understand the risks associated with 3D printers. And so, you know, when we look at the hype curve, I'm trying to think of the name. There's like a technical name for the hype curve, but we look at the hype curve. We are certainly on this uphill of the hype curve. I worry that we're going to quickly cross to the downhill when there is a major safety issue that affects an end user. If it affects a hobbyist that understands the risks, that to me is less of a problem than it affecting, like, you know, the family that bought one for little Timmy for Christmas that doesn't understand the risks associated with it.
And it makes it worse when, even in that scenario, when you're buying it for somebody else, say it's their first machine, it's normally a cheaper machine, meaning they've cut even more corners.
Yeah.
So the risk is higher. And that is the thing that petrifies me, is people need to learn, but they can only learn via experience. If they can only learn via experience, it means they have to experience something. And normally you're not going to give them the best, greatest machine going, because they're still learning. So it's like you wouldn't train somebody to do wood carving with a bad quality knife. You just wouldn't, because it's too dangerous. However, we're in that kind of scenario where we're giving people bad quality knives, but it's 3D printed.
But the funny thing is, I feel like Creality has just as many Ender 3s out there as Bambu has machines. A lot of those Ender 3s are ending up in scrap bins, in landfills and things like that. But we had less Ender 3 fires than we currently have Bambu fires. So, and Creality has had a lot of issues. Creality shipped for months Gen 1 Ender 3s with no thermal runaway protection at all.
Yeah.
Those thankfully did not result in fires. A lot of the fire issues that we saw in Ender 3s were 100% user-based, where they made modifications to the machine heavily, where they were like changing out heater cartridges, and instead of changing out the whole wiring, they cut it and they soldered it. Like, I totally, like, that to me is not on the company. Stock machines, we saw very, very few fire issues with stock Ender 3 machines. And I feel like we're seeing a lot more out of Bambu. But then we also look at the stock Ender 3 and say, well, there's a lot less plastic on it. So if there was a potential fire risk on an Ender 3, there's a lot less stuff for it to burn.
Yep.
But do we look at it and say, well, the Ender 3 has to be our example, since at one point they were selling for $99 US.
I know. I have a $99 US one.
Like, if that machine can be safe, then in my opinion, there is no excuse for a Bambu not being safe.
Yeah, no, you're right. There is nothing you can argue against that. There's no counterpoint. It is, if the cheapest machine you can physically buy that still turns on is safe, why is the expensive ones not? Hell, that was the reason I even started the company, was why is the cheap ones better than the expensive ones? The type of people that were buying Ender 3s were already the type of people to go on the forums, which is the type of people who are buying the A1 and had the fire and went on the forum. They're the same person as demographic. Like, Reddit's demographic did not change that much, neither did the forums or anything. The difference is, however, there's now just a lot more machines that aren't in the same maker's ecosphere, which is what we're used to, where reporting bias then really does kick in, where the Ender 3, anyone who bought an Ender 3, they were in the hobby. They had to be, because otherwise the machine was not working. They needed to mod the machine.
Maybe there were fewer risks because people understood those risks. And so when it happened, they often assumed it was their fault versus a machine fault. So there are a lot of what ifs and, differences. I definitely believe that the reporting bias, 3D printing popularity, and just user understanding absolutely played into the fact that we saw less reports of fires from Ender 3s. I just don't know if it's enough for me to let Bambu off the hook. Because I don't let Chidi off the hook. I would never let Prusa off the hook.
No, you shouldn't let anyone off the hook. The problem is the government has let them off the hook.
Yeah.
And it's our job, as much as I hate to say it, it's our job to be the stickler in the mud going, my printer shouldn't catch fire. That's what we need. Otherwise, nobody's going to do it. They don't get any legal recourse unless somebody dies. And even then, they could probably argue their way out of it. There's no incentive for them to actually improve what they're doing, because why? They're earning infinite money.
Right.
Why would they do anything?
The incentive is completely missing. There isn't an incentive.
Yeah.
You're totally right. The incentive isn't there. If they're not being held accountable, why is there an incentive to do better? There isn't.
Yep.
The incentive is to make more money. And if you're not being held accountable in the world where we push capitalism, pure capitalism. And I'm not going into, personal opinions regarding capitalism, but, when we push pure capitalism, there is no reason whatsoever to make a product any better if we are not being held accountable for our issues. And that's where, as content creators, myself and others, we end up becoming the ones that have to point the fingers and say things. And unfortunately, while there were how many dozens of people spoke up about the Chidi fire risk versus this, we're the only ones talking about this. We're the only content creators talking about this. And maybe that has to do with people's schedules. Maybe it has to do with, that they're working on other things. Maybe it's because they didn't see it. Maybe it's because they don't care. But I know there's a strong part of it that is Bambu feeds us. We're not going to bite the hand that feeds us. And yeah, I get it. But at the same time, as a lot of people think that I'm a Prusa shill, they've given me machines, they've never given me money, right? A lot of people think I'm a Prusa shill. If Prusa had a fire risk like this, I'd be making the same damn video. In fact, I'd probably be harder on Prusa because I have all this video from their factories showing how safe their machines are and how much effort they take into doing it. I think Prusa would get a harder hit from me than Bambu does.
I don't know, because it will happen eventually.
It will.
It just
Prusa
will.
has no excuse, though.
Now,
Bambu can blame it on a myriad of third-party manufacturers. Prusa can't. Prusa's vertically integrated. Outside of making those raw components themselves, so unless they got a reel of bad parts and they can trace it back to the reel of bad parts, Prusa has no excuse at all.
I could give them an excuse. They don't do 100% quality testing, and that is unreasonable to expect.
Every single board is tested.
Tested, but does not mean every component is tested.
They go through.
So it could literally just be on the reel of crimps. Mm-hmm. One crimp is slightly bad.
Gotcha.
One crimp gets through because it still works. That could be the point of failure.
But I think Prusa would get in front of it. I think they would, because they've gotten in front of this.
Oh no, they would. They would immediately treat the person with every respect they need, because that's what Prusa stands for.
Like the VFA issue, it is not happening to every core one. It's happening to a few of them. And I would say half of them, right? Prusa got in front of it before more reports have come out. Now that Prusa's in front of it, there's all these new people coming out of the woodwork saying, oh yeah, I have this issue too. They had no idea they weren't supposed to have this. While that did have a little bit of pressure associated with it, it was nowhere near the pressure that I would remotely apply when it comes to a fire. Fire, you get the fire of the Cuban side of me in terms of pressure. You don't get the, maybe we should deal with this kind of pressure. I think Bambu has done a good job so far as to manufacturing a good machine. And so part of me doesn't want to put this on Bambu, but the same way that I would take responsibility if something that we were doing had a problem, I think Bambu should step in and take responsibility too. Obviously, They need to completely replace these machines. I do not think that it is a good idea for anyone to be doing that kind of work inside of their machines. But I would love if Bambu would do a dive into what caused this. Acknowledge that it happened, dive into why it happened, and then allow the community to become better educated as a result. That would be the win.
Even if it is just an engineer or a marketing person saying, hey, we've designed around the chance that this could happen. Here is why it's not actually an issue. It could just be the material that we made the bottom of the machine from is non-flammable to these type of environments. And I'm like, you know what? I believe it.
Good enough.
That's cool. Yep. Thank you for saying that. Just some form of acknowledgement and
not
even a reassurance. I wouldn't even go as far as a reassurance, but just we're aware of it. The risk is minor. That is good enough for me, because at the end of the day, even if it's not a V0 material, the likelihood that it would have propagated is already quite low.
It is. It's It's not like the ANET A8s of yesteryear where they were made of flammable acrylic. It's not a fire starting at the hot end, dripping onto the part that is made of a flammable material. There is a lower chance and a lower risk of fire with modern 3D printers. We are seeing that there is a higher risk of electrical failures that can create a fire environment. But the fires that we think of the ANET fires, those are considerably less likely, even in current situations.
Oh, yeah. Like, just changing away from acrylic, which is basically just a fuel source at this point. Yeah. If you're using acrylic in a machine, I'm just going to turn and ask why, because that is solid fuel. The moment it starts burning, it is gone, and the rest of your building is gone as well.
Well, enjoy the rest of your day. Stay safe out there. Don't forget to call your loved ones. And of course, as always, keep making awesome. Yeah, we're not lined up for that.
That didn't time it,
no,
did it?
That didn't time it. The timing was not great.
I was trying to get the sync.
Okay, that's the comment. If I do something stupid, I should be bit for that, right?
If there is smoke and ash, there is fire.
Only you can prevent forest fires.
If I still think that
if I stick a fork into the electrical socket, I want to ride the lightning, okay? I need to feel that I'm an idiot. Like, when I was working on my well...
Legally, though, you wouldn't. It would be the fuse box company would get sued.
Sir, this is the United States. It's not how that works.
Please tell me you're joking.
I'm not joking at all.
I have just lost so much faith in your country.
Yeah. It's never gonna sync up right. It's fine. Don't worry about it.
Keep making awesome, people. There you go.
Keep making awesome.
Done it.
Okay.